We were taught that the universe has rules, that space is a stage and time is a constant. But there are places where the stage collapses and time simply stops. Welcome to the event horizon, the point where the universe itself breaks. A black hole is not a hole at all. It is the most crowded place in existence. Imagine a star 10 times the size of our sun, collapsing under its own weight until it is crushed into a space smaller than a city. It is a concentration of mass so extreme that it warps the very fabric of reality. For decades, we viewed them as rare cosmic monsters, distant and irrelevant. But we now know they are the silent anchors of every galaxy, including our own. As you approach the edge, the event horizon, the laws of physics begin to stutter. Light, the fastest thing in the universe, is no longer fast enough to escape. Therefore, the black hole is the only place in the cosmos that is truly, perfectly dark. But the real horror isn't the darkness, it's the gravity. It is so intense that it doesn't just pull on your body, it pulls on time itself. From the outside, you would appear to freeze, trapped in a single moment of agony forever. Inside, however, you are falling toward a point of infinite density, the singularity. This is where our understanding of the world fails. A black hole is a shift in the most literal sense. It represents the moment where matter becomes nothingness, yet retains all its power. We used to think of them as destroyers, but the math tells a different story. They are not just cosmic vacuum cleaners, they are the engines of the universe. To understand how these monsters shape the stars, we must look at their birth. A black hole isn't born from peace, it is born from the most violent death a star can experience. Every black hole began as a beacon of life. To understand the darkness, you must first understand the light. A massive star is a titanic engine of fusion, a delicate balance between two opposing forces, the outward pressure of nuclear fire and the inward crush of its own gravity. For millions of years, this balance is perfect, but stars are fueled by a finite resource. Inside the core, hydrogen fuses into helium, then carbon, and eventually neon and oxygen. Each stage is a desperate attempt to push back against the relentless pull of gravity. But eventually, the star reaches iron. Iron is the cosmic dead end. Fusing iron consumes energy rather than creating it. Therefore, the engine stalls. In that split second, the outward pressure vanishes. Gravity, having waited for eons, finally wins. The iron core, a sphere the size of Earth, collapses to the size of a city in less than a fraction of a second. The outer layers of the star rush inward at a quarter of the speed of light, slamming into the collapsed core and rebounding in a supernova, the most violent explosion in the known universe. But if the remaining core is heavy enough, even the explosion cannot stop the collapse. The core continues to shrink, passing the point of no return. It crushes past the limits of atomic matter, past the limits of neutrons, until it occupies zero volume with infinite density. This is the shift, the moment a physical object becomes a mathematical impossibility. A sun that once gave life has committed suicide, leaving behind a ghost that now consumes everything it once illuminated. We think of death as an end, but in the cosmos, a star's death is the birth of an absolute sovereign. It is no longer bound by the laws of thermodynamics. It has become a master of the dark. Now that the monster is born, we must ask, what happens if you get too close? To enter a black hole is not just to travel through space, it is to witness the unraveling of time itself. If you were to fall toward a black hole, the universe you leave behind would begin to look like a distant, fading dream. You are approaching the event horizon, the cosmic border where the exit signs are permanently turned off. As you get closer, a terrifying phenomenon occurs: gravitational time dilation. To an observer watching from a safe distance, your movement would appear to slow down. They would see you hovering at the edge, reddening and fading into a frozen ghost. But from your perspective, time is moving perfectly normally. In fact, as you look back at the universe, you would see billions of years of history flash by in seconds. You are watching the future of the cosmos unfold and die, while you remain trapped in the present. Then comes the physical shift. Gravity is no longer a uniform pull. It is a gradient of destruction. If you fall feet first, the gravity at your toes is millions of times stronger than the gravity at your head. Therefore, your body is stretched like a piece of string, a process scientists call spaghettification. You are being dismantled atom by atom, not by heat or blade, but by the sheer curvature of space itself. But the nightmare doesn't end with your destruction. Once you cross the event horizon, the roles of space and time are reversed. In our world, you can choose to go left, right, forward, or backward, but you must always move toward the future. Inside a black hole, the singularity is no longer a place in space. It is a moment in time. Therefore, falling toward the center is as inevitable as tomorrow. You cannot turn back, because to do so would be the same as trying to travel back to yesterday. Inside the dark, the laws of the universe haven't just changed, they have inverted. You are no longer a traveler. You are a piece of information being compressed into a point where and when mean nothing. But if a black hole is a one-way street to oblivion, where does all that information go? Could the end of one world be the silent beginning of another? If a black hole is a one-way street to oblivion, we must ask, where does everything go? The stars, the light, and the very information that defines our reality are swallowed by the dark. For decades, we believed this was the ultimate end, but the universe rarely wastes its resources. Therefore, some of the greatest minds in physics believe that a black hole is not a drain, but a vault. Stephen Hawking discovered that black holes are not perfectly black. They slowly leak a ghostly glow known as Hawking radiation. They are evaporating, exhaling the energy they once stole. But the process takes trillions of years, longer than the current age of the universe. This suggests that the black hole is a cosmic hard drive, storing the data of everything it has ever consumed on its surface, the event horizon. We are not just watching a star die, we are watching the universe record its own history in the most secure way possible. But there is a more radical shift. If space and time are crushed to a single point at the singularity, the pressure might become so extreme that it triggers a new expansion, a big bang on the other side. Therefore, every black hole in our universe could be the birth canal of another baby universe. We might be living inside a black hole ourselves, a fractal chain of realities nested like Russian dolls, where every death in one world is a genesis in the next. The real shift isn't about physics, it's about perspective. We used to fear the dark as a predator, but now we see it as a silent architect. Black holes are the anchors that hold galaxies together, the crucibles that recycle reality, and perhaps the creators of life itself. Without the darkness, the light would have no structure. We are small, flickering lights in a vast, gravitational sea. We spend our lives trying to illuminate the dark, only to realize that the dark is what allows us to exist. Are we the masters of our world, or are we just the fleeting thoughts of a monster that hasn't finished dreaming?